Welcome, developers, leaders, recruiters, and friends on LinkedIn. My name is John Beluga, and this is How to Think in Blazor. Feel free to email me at john@johnbeluga.com if you have any questions or feedback. You can also connect with me on LinkedIn, see other past recordings on YouTube, see other open source projects I have going on GitHub, and upcoming talks I have on Sessionize. If my website looks like it was done in PowerPoint, well, actually it was. You can step and scroll through the different slides. You can also click on different links to the slides to jump around the site. On the left-hand side, there's a navigation bar to different slides as well. You can also toggle animations. And what's pretty cool is that you can actually press play like a video inside of here, in which you will hear my voice cloned. And the reason I want to kind of show this little clip is that in the upper right-hand corner, you'll see demo if I have any recordings that are within the slides themselves. On my website, you'll notice here there are 3 different ways you could work with me, whether it's an advisory, a certain project, or if you need me to do a whole solution. I also work by the hour as a subcontractor, but when I work directly with anybody, I provide 100% guarantee, and my first meeting is always free. This talk is one of 2 talks that I gave at a recent VS Live conference. This talk itself is more like a part 1, to where the second talk is almost like a part 2 because of the number of examples that I have in Blazor. The second part, this other talk, I'll be scheduling in a couple weeks and have recorded as well. The source code and slides for this talk are in a GitHub repo. There's a bit.ly link of John Beluga VS Live that you can access. The slides themselves are both available in PowerPoint format and PDF. I recommend the PowerPoint format due to the animations and demos that are part of it. Also, these slides, the updated ones, were added as well. So my software development go-tos, of course, Blazor when it comes to mobile, web, and desktop. But within the Blazor ecosystem, I really like the Rats and Blazor components as well as the Octane platform, which is kind of like WordPress for Blazor. I heavily use VS Code, but I primarily use VS Code when it comes to my AI development or utilizing AI with GitHub Copilot and Claude Code. I'm still a big user of using just good old Visual Studio for my .NET development, including Blazor. I do a lot with PowerPoint and Access in particular when it comes to development and integrations. So yeah, these are my software go-tos. So I thought it'd be nice to put a little AI disclaimer in here. 95% of the code, and there's a lot of code that I share and then that will also be kind of walking through, was actually written with AI tools with a lot of my guidance, including the VBA and Access database. I utilize AI to kind of work through that, and I'll share my techniques there. That's really more for the next talk that I'm giving about Office development, but it's out there. I also use GitHub Copilot and Claude Code both within VS Code. And like I mentioned, when it comes to this presentation, I'd say I probably use AI for 10% of it outside of my normal questions with ChatGPT. So quick overview. What this is about, the agenda, and overview of the demos. So for what this is not about getting started in Blazor. This is a intermediate level talk. I definitely try to bring some things up to speed, but this is not really demonstrating a hello world in Blazor and stepping through stuff like that. But it's also not a talk where I'm going deep into Blazor as well. We do talk about coding patterns and things like that, but I'm not so much getting in the weeds on how things work when it comes to within the browser and how things are interacting. And this is really not about saying that Blazor is better. You might be happy with your current tech stack and you're trying to just understand more where Blazor fits. I tend to think, I'm a little biased. I do think Blazor is better, but I'm not really trying to sell you on that. I'm really trying to, clarify how to really think about Blazor. So yeah, what is this about? This is how you should compare Blazor to other options and how you should approach your coding standard within Blazor by looking at real world examples, most of which I provide, and overall how you think in Blazor. So I am assuming you're not new to .NET and C# development. You are familiar with Blazor to where you maybe you've been through some demos or watched some training on that. And also you're familiar with web development. It's, the basics of HTML, CSS, and JavaScript. So I had those assumptions. So when it comes to how do you think in Blazor and the agenda for this talk, we're going to be looking at the comparison perspectives first. And there's three ways to compare, or three ways to look at Blazor when it comes to how you evaluate it. That's the web developer perspective, application architecture perspective, and the Microsoft developer perspective. When it comes to coding approaches, how you should be looking at embracing a platform, then a component suite, as well as then a coding standard. And a lot of people get these approaches backwards, but it's very important to recognize where are you headed for the whole solution. Next, we'll be talking about how you really leverage the architecture. So the data binding basics, we'll cover a little bit of that, but we're going to be talking more about like coding patterns for data access and how to best implement JavaScript with Blazor. That seems like to be one of the bigger hangups of what confuses a lot of developers new to Blazor. And is Blazor the right choice? What are the decisions you really need to work through? And we'll recap on the perspectives and the order of choosing. In between all this, I am going to review the sample code that I provide. It's a lot. So yeah, in between this, well, I'll kind of walk through the architecture of what those different software solutions that I have out there. The sources and slides, I leverage Brent Stewart's Blazor Basics repo. Now, he gave a presentation on the Blazor Basics, and I do show some demos from his talk that were very valuable on the basics, and I got Brent's permission to do so, and he said, go right ahead. NetOffice. The reason I want to point this one, and this is really for the Office talk, but I kind of highlight that second link, that open source repo is needed for the open source code as a whole. I'll clarify that later, but it's just good to be aware of that. It's a piece of open source that you would also need to include, or a repo. And then when it comes to the source code for the Explore the World source and slides, the link is there, or you can use the bit.ly link to go to that. So there are 4 different solutions actually that I created. Solutions meaning really a lot of the same projects underneath those. So within this talk, how to think in Blazor, we have the Blazor web app solution and the Blazor lib Radson solution. We'll cover those more later. And we also have 2 more solutions that include a lot more code, actually, a lot more samples. And that's at a higher level type solution of just the Explore the World.sln. And then there's one for .NET Framework, which again, those are more so covered in the second part. So as for a quick demo to see what the sample code looks like, there's this API that you could utilize on your software for free, where you can query country data and states and flags and that kind of information. So we have 3 different UIs, user interfaces, that were created. One is to collect and export the data. Another one is to present the data as slides within the web page. And then there's another one where you can watch an Office app. Now that third user interface is really doesn't really pertain to this presentation, but it does pertain to part 2 when it comes to programming Office apps. So the web app for this country's now, you can basically uses the API and then uses the database for caching. So you'll notice little indicators of the source of API or database. So once you kind of click on a country and see its states, you'll see where it's coming from. And also down below, you can actually export in the different formats, which is a nice feature to have. So a little bit of a wrap up on this screenshot. You can choose the different type of export that you want, as well as the different libraries you have. Now, for our web app, you can only utilize OpenXML. But when it comes to exporting data with the various Office APIs, you can do more with desktop applications and add-ons. Also, the server-side app as well as the WASM app are 2 separate projects, and actually does auto mode to where it be server and then switches over to WebAssembly. So those of you familiar with Blazor, you'll see that kind of interaction and the different data stores that you could utilize. So for that API data, it can just go into it in memory, or it could be SQL Server, SQLite, or Access data, or an Access database. No, you wouldn't really want to use Access when it comes to a server application, but I went ahead and created the implementation anyway. And on the client side, within the web browser itself, you can cache that data in the memory of the application as well, or one of the three browser storage techniques with local storage, session storage, and IndexedDB, which all of those are implemented as well. So you can press F5 in order to see the switch over from the server mode to WebAssembly. So that's just good to be aware of that. You might just see server, but if you press F5, then you'll see that it was that it downloaded WebAssembly, and that auto mode is implemented. And one of the latter demonstrations of when it comes to how you really should consider doing a platform, I utilize Octane. So then the demonstrations later, you're going to see how we have this countries now component incorporated as a module within Octane. So we have the same application within Octane as well as having a custom theme within Octane based on the Radson component suite. And the last little demo as we kind of jump into stuff, when it comes to where you can see slides, where we're still using the API and caching for database, but we can present the country data as a presentation. With inside of here, we're using Reveal.js, which is a JavaScript library being controlled by Blazor. So now let's kind of move on to the comparison perspectives of being a web developer versus looking at the architecture versus coming from the perspective of a longtime Microsoft developer. So first, this is just a little shout out to Brent Stewart. A big thank you for letting me utilize his open source examples here. So Blazor Basics within his repo is what you want to consider pulling down as well. And just to give a little bit of a demonstration of what you can see here, we have the different render modes. So again, this is a great sample application to kind of take you through a lot of different aspects of Blazor that are a little bit they're a little bit maybe even assumed in this talk, to where if you want something that's a little more direct to explain things a little bit better, you might want to leverage this open source tool or open source code. Let's look at a little demo of rendering modes. So what's nice here is that you can, look at static rendered or server-side rendered. Then you got server, WebAssembly, and what's nice is that Brent has incorporated, what kind of takes place with each render mode getting triggered. But a lot of us have come into Blazor looking at, well, the sample application that we've seen multiple times over, especially the counter. So a lot of us look at this as our point of evaluation. And when you look at that code a little bit better, or a little closer, you notice that you see this example, and the counter example is probably looked at the most, of how you can wire up, Blazor code within the HTML. So a lot of people take the approach of taking this example and comparing it to others. So taking this example, comparing it to others, you'll look at maybe where you have like React, Angular, and Vue, and you'll find some examples out there. I went ahead and generated some of what that kind of looks like. And so many people get caught up here when there comes to evaluating Blazor. Comparing the syntax of Blazor versus React, Angular, and Vue, or just raw JavaScript and whatnot, or another framework, that's just the beginning. You really need to move past these hello world or hello counter examples as soon as possible if you're truly evaluating Blazor. The application architecture perspective is really how you want to spend most of your time looking at Blazor, because Blazor is not the same as React, Angular, and Vue. Even though you want to kind of compare it at a code level, it's simply different. Blazor first came out with this server version where it utilizes SignalR for the interactivity. And then not too long after that, it came out with the WebAssembly version. And really, React, Angular, and Vue just didn't kind of fit in this kind of way of doing things. And then later on, Microsoft came out with the non-interactive version. And this is where things started to make a little more sense on where things kind of fit. Also released around that same time, there was the auto mode of switching between server and client, and the Blazor hybrid as well, where you can kind of do desktop applications with Blazor and mobile. It's really within this non-interactive mode, which is now the default, to where you could utilize React, Angular, and Vue, or even jQuery inside of your web application. It's similar to, the non-interactive is actually similar to the older stuff with web forms and MVC. And coming in .NET 11, there's going to be more MVC feature parity to where Blazor and MVC just are going to be really the same thing moving forward. So Blazor itself just simply provides more architectural options to where with React, Angular, and Vue, in many ways, it's just a front-end library. And there's other server-side architectures as well that you could choose over .NET. But still, if you're wanting to stay in the .NET ecosystem and you're happy there, you could definitely leverage Blazor to keep you even more happy. You can focus on business problems more. The more that you're kind of battling different technical issues across different technologies, you really do kind of get pulled away from solving problems. And that really makes Blazor this true full stack solution when it comes to what you can do on the front end and what you can also do on the server for application development. So from a Microsoft developer perspective, when we look at Blazor being able to handle mobile, web, and desktop, you might be looking at it from the perspective of coming from web forms or MVC, or you might be coming from some really old stuff like a Access Database or the ASP Classic. Then you might be coming from a desktop application like just WinForms, WPF, or even the old Xamarin stuff or .NET MAUI. And then, of course, you have your more traditional web development front-end frameworks that you might be looking at Blazor to kind of do a little more standardization. But also you can consider Blazor for doing office development and add-ins that a lot of people aren't really aware of. But again, that'll be covered in a part 2. And when it comes to hooking into different AI aspects, there's the Microsoft Extensions AI package that you can include to kind of hook into these different large language models for various purposes. All three perspectives are important. You do want to have a syntax you can work with. You do want to have an architecture that's strong, as well as, if you're wanting to kind of help your Microsoft developers move forward, that's a good thing to consider as well. But if you had to weight these for what, is more important than others, comparing the syntax of Blazor to React, Angular, and Vue, it's weighted really low in my opinion. It's, 20% of the decision. And then if you're coming from, the Microsoft developer perspective, that's important. If you have a developers already programming in .NET and C# and they're happy, that's a good, strong reason to consider doing that. And really, it's this perspective of the architecture itself. And that's where, I would say that outweighs the other two equally when it comes to deciding to go with Blazor. It's because you want this architecture. The different coding approaches that you consider, I would first look at considering a platform, and then a component suite, and then a coding standard. Let's look at different platforms first. And I purposely wanted to look at platforms that truly implement Blazor that were open source. So I found this ABP, this clean architecture open source solution, as well as Octane. And we're going to talk about the different considerations as well when it comes to meeting your long-term needs, access to the source code, and just the business model of a platform. ADP looked interesting, but it looked like it was trying to serve all the different tech stacks. In other words, I found Blazor in there, I found MVC, I think I found some React, but it's a solution that tries to implement Blazor as well as other aspects. The clean architecture open source solution looked interesting in regards to there's a lot of emphasis on using the clean architecture pattern, which is a good pattern. The demo code that I have out there is a slightly different pattern. It's more focused on how you're managing dependencies. But if you want to see something that has a clean architecture, you should check this one out. That's in Blazor. Now, Octane is my go-to when it comes to a platform for a good number of reasons. It provides a lot of the basic aspects that you need when it comes to administration. It's open source with an MIT license. I found there's a lot of reuse. It makes it very easy to administer various pieces, and you can really leverage moving fast on delivering various components, pages within your overall platform. Now, some questions to consider when it comes to a platform meeting your long-term needs. Does this platform scale? Is this platform well supported? Is there a strong buy-in from the team? That's one of the bigger ones. Really having the team kind of really enjoying and understanding a platform that they're coding within has a lot of value. Access to the source code is important as well, especially with the AI tools nowadays. It's good to have access to source code. Now, MIT is definitely the one that's preferred for most platforms, but GPL, AGPL, I mean, really, many of those are just fine as well. It's just you got to work within the limits of the licensing. And when it comes to a business model, looking especially for a platform, when the creator of the platform, like for example with Sean Walker and Octane, when they're actually out giving talks and talking about open source sustainability and what their business model is, having that level of clarity of a platform creator goes a very long way. So when it comes to embracing a component suite, there are a good number of component suites out there. I kind of chose the spectrum of them. So where you have Telerik, I could also chose like DevExpress, Syncfusion, some of these other paid components. Blazor is a very popular open source library. Then Radson is one that's open source as well, and it's one that I prefer. And the different considerations are more along the lines of, does it cover 90% of the UI features that you need, and also access to source code and business model are important here as well. So Telerik, has hundreds of components that you could utilize. It's kind of your typical pay for component suite that many of us have come across. They sponsor a lot of conferences, and they have some good stuff. Blazor is probably the favorite amongst the open source community. Just the community support is just really strong for this solution. Oh, it is MIT licensed as well. When it comes to Radson components, those are also open source and MIT. And they also offer this Radson Blazor Studio, which is something you have to pay for, but it might be a value. We'll continue to use Radson as an example here when it comes to things that you should consider as a basis of evaluating a component suite. You want something that's well documented, that hopefully makes a lot of sense across any component suite that you want to support. Another thing to consider is the design system. You want a component suite that has guidance around how you manage styles and themes. A lot of your big ones do, such as Telerik, but not necessarily all your open source solutions have that. So recognize that you want to see if there's a good design system around the components themselves. And the components themselves, they need to be good enough to where the base components, you want to reuse them in your own components that you create. So you definitely want to reuse various base components. So as Matt mentioned, you want to have access to source code. So typically out on GitHub and Radson's MIT license, same as Blazor. And when it comes to business models, recognize that for components like Telerik, you might be paying for components and support, but you do have access to source code. that is one thing that may not be obvious for some of these paid for component suites now, that they do give you the source code when it comes to utilizing, a lot of times your AI tools really want that source code to understand how a component works or how code works. So it is nice that Telerik and others give access to the source code. Blazor, as mentioned, it's MIT license, very strong community support, but really no clear business model. It's not clear who to call or if you can even pay for support somehow. So you have to recognize that with a component suite like that. And then we have Radson. Yes, they have MIT license and pretty good community support as well. They sell this designer, which comes with support in general for the component suite. Radson Blazor Studio, this is one thing I want to kind of share, is that, design time tool basically looks like runtime. In other words, I do a lot with AI. I don't really do much in the designer itself nowadays. Of any designer, I'm not really drag and dropping components. But what's nice about Radson Blazor Studio, I just want to highlight that, when I'm kind of generating code with AI tools, as soon as those files are created, I see the change inside the designer without even running the app, even at a component level. So you can really narrow things down. And you'll notice that even data is loaded inside of here. So what's nice is that within your designer, you can load it up with real data, fake data, to really get an understanding of how that component is behaving. So embracing a coding standard, let's look at the different aspects of a coding standard and different considerations of, view-centric versus code-centric and so on. So using a design system, especially going through the documentation for what a particular design system has to offer, you're going to want to see that, that it does support responsiveness, out of the gate, and even media queries and things like that. So, and the sample apps I have in the header bar, I have a little badge that indicates how it's viewing things at a responsive level. So yes, you want to be able to trigger on different breakpoints like you would with any design system of how the UI gets rendered. So when it comes to Radson Blazor Studio, that'd be good to kind of show a few more things inside of here to help kind of even clarify more what you can get out of a design system that's even based around a designer. So I haven't really come across as good of a designer like this since honestly Access or VB in those days. So we have the properties, which kind of maps to the code where you can either change the code or you could change the properties, such as the caption, the clear database, or that button style of danger. And the way styles are managed. So for the styles itself, if you want to use a particular class, you can kind of note it there or in the code, or you can actually, scroll down within that UI there and actually change the code or change the property settings with inside the panel. And lastly, inside of the Radson Blazor Studio, you have the events tab where you can kind of see the different event handlers that you can utilize, such as the clear database async. When it comes to reusing base components, let's take a closer look at reusing the Radson component. So highlighted on the left-hand side, the Radson component and all of its different properties, base level properties like visible and even hooks into an element reference, have a lot of value when it comes to, not redoing a lot of work. So I use the Radson component as my base. It's the base of my base component. And you're going to see this example here shortly. I hook into you can hook into element reference events and like mouse enter and so on. You can also implement, a standard strategy for handling visibility and other aspects of a component. So the country's new component, you'll notice that, it inherits this base component, base Radson component, which is, we're going to take a look at that shortly as well. But in this component, we implement visibility. So at the very top, if it's not visible, then just return. but also implements a standard that I find in many of the other components in the Radson suite. So if you don't provide an ID, it'll generate one for you. It works with the standard way of pulling together the class that should be applied to the overall component and so on. That get hidden style is part of the base component. So in the base Radson component, I also inject a lot of the common services, user services within the application that's not only provided by standard Blazor development like IJS runtime and navigation manager, but Radson has their dialog service, tooltip service, context menu service, and a notification service that are useful. And then down below, we have the hidden property. So you can mark your component as hidden, and it'll simply toggle the display of your component versus not rendering at all. This is useful for some JavaScript libraries. So you also want to consider using components over creating pages directly. And let's take a closer look at Octane to understand why. So within Octane, you basically configure your different components and modules for what displays in the main area. And Octane itself is what manages pages. So let's see a demo of this. So in this demo, we'll go to like the my page component, or page, I guess you'd say, or that uses the HTML component, where you can edit it and so on. This is what's built into Octane to have a simple HTML page. And then we go to countries now. You'll notice you could be running it as well as you can edit it. It's actually even still running while you edit it, which is kind of cool. But then here you can also manage settings for where you want it at on the page if you have multiple components, and just permissions around it as well. So the Octane module is really kind of a wrapper for doing the components in a Razor library. So I purposely only put as much into Octane as what Octane needs. So it's really a wrapper for that countries now component that resides in a Razor library that could be used by Octane or anything else. And within that module, there's this module definition that you want to provide that provides the basics of your name and default permissions and things of that nature. So some considerations, view versus code-centric, HTML component-centric, and we'll talk a little bit about view models and some aspects when it comes to keeping your code AI-friendly. So here's a demo I put out there. It's kind of a standalone demo of all-in-one, doing everything in one file. So you can put your HTML, your JavaScript in this example, your code, C# code in there, as well as your styles. Could all be in one file. And then this is the example to where, it's just doing you put in your name and then show a greeting, show a little pop-up. And that's what in this example, the JavaScript is needed for, to show that alert. So here's the same example, but broken up across different files. So we have the Razor or HTML code separate from the C# code. And then you can have your CSS code within its own file as well, the style, and then the JavaScript itself. It could be in its own file. And again, doing the exact same demo of doing the pop-up with the alert. Now, in looking at a Radson demo, doing the exact same thing, or pretty much same thing, we have a side-by-side look at the component view versus HTML, and also side-by-side of the .NET C# code as well. And this is actually going to use the dialog service as part of Radson to do that interaction. So as a demo, you put in your name, hit show greeting, and that show greeting is handled within Radson component suite. So what you start to notice is that you have less of a need to have a separate .css file and kind of encapsulating specific things to your component. You really want to embrace more your design system instead of having custom CSS everywhere. And when it comes to having custom JavaScript within your components, you'll notice later when I demonstrate there's a better way to kind of handle controlling these dependencies on leveraging JavaScript where you need to. So what about view models? Should we use them? Should we not? Well, it depends. That's a good old consultant response, but it truly does. It depends on how complex things are. So if you need to manage multiple inputs and languages and things of that nature, yeah, you might actually want to do more of that within a view model. But you know, the more the complexity, then yeah, the more you might want to need a view model. So I have a list here of when you probably do want to use a view model, and it's really in summary. Yeah, when things are more complex, yes, you might want to use a view model. And when to avoid using a view model. So when things are not as complex, that's when you simply may not want to use a view model. For the sample code that I put out there, I purposely did not incorporate view models to keep that part a little more easy understood. But again, it depends on your situation. So when it comes to making or working with component suites or an architecture in an AI-friendly way, looking at where you can include a chat or even an MCP server to help generate code, that's not so much what I'm referring to as being AI friendly. Really, we're talking about different, working towards different patterns and practices in your code itself. So a lot of us that are heavily working with these different AI tools recognize that we want to document our code. So when it comes to not only just documenting the architecture, but even documenting how we want that code generated has a lot of value. Matter of fact, this documentation was created by me saying, add these instructions. And it did kind of note that in the appropriate structure. So when you look at an example, this followed the instructions to where the alignment, it has all the different settings, the attribute settings on one line like we would want, but you're optimizing for readability nowadays more. You're not so much optimizing where you have everything on one line. And you'll notice my naming standards, are pretty verbose. I still use a double underscore in many areas, but nonetheless, you'll see more like when something is a component, I say it's a component or an interface to a repo. I purposely spell out a lot of these things that are not generic .NET objects in order to kind of make code review go faster. So a little bit of a summary, how to choose your coding approach. You want to choose your platform and then your component suite, and then choose your coding standard. Now, it's not like you're kind of purposely looking at a platform first and not looking at the other factors. You're looking at all three of these factors. But when it comes to making your decision, you probably want to, consider that platform first, consider that component suite next to make sure the platform, can support that, as well as, having a standard that works well across all three. And in choosing your stack, we see a lot of different stacks out there, the LAMP stack, the mean stack, and MERN stack. These are all takes on more so in the web development space, like, pure JavaScript or PHP for LAMP stack. And then we have the .NET stack. And when we talk about being .NET developers and that's our stack, we're talking about the runtime and just maybe the web server itself and the language of C#. But we need to be a little more specific, I think, nowadays. So we should consider the .NET stack with, what Blazor implementation in particular you're kind of looking at doing. So you got, think of Blazor and the component suite and the platform. What is your stack when it comes to being that specific within your technology suite? So as an example, you got the Blazor. You might want to use Mud Blazor and the clean architecture. So you got the BMC stack. You have Blazor and Bootstrap and Octane, because Octane really, by default, uses Bootstrap. So you might want to have the BBO stack. For me, I like the Blazor Raisin Octane stack. The BRO stack, I keep calling it the bro stack, something you don't forget. May not be the best name, but again, it's something you don't forget. So let's look at the sample code. Probably more than just samples, but we're going to look at the application code that I created, compare and review the features and the overall architecture as we move forward. So we have this country space.api. We did cover some of these demos already, so I'll go through them a little quicker. We have a UI to collect and export data, present the data, slides, and also there's this watcher of Office apps that, again, that's more of the next part. The solution itself, especially the top level solution, has a lot of projects. They're kind of grouped together in a way to where all the apps, all the things that you can right click and set as your startup project to run, they're all grouped underneath an apps folder, an app solution folder. So it makes it a little easier to kind of right click and then run that implementation. So countries now, a little bit of recap, that's a screen that allows you to kind of have the API, utilize the database for caching. You can also export Word, Excel, or PowerPoint, and choose the API for that. So it's implemented in the auto mode, where it can be server or WASM, or just WASM, which we have on the right-hand side, which that kind of dictates which database you kind of use for caching. And of course, we the Octane implementation as well, where we have not only just the countries now as a module, but we have a Octane theme that's utilizing Radson as the component suite. So of all these sample applications, this particular talk is really only talking about these first three implementations of the web app, the web app that's client only for WASM and Octane. There's a WinForm implementation, there's a Maui app implementation for Windows, Android, iOS, and Mac, as well as Access. And there's also these different add-ins that were created as well. And so those, again, these latter ones are going to be covered the next part. I also added these different feature matrix. So when it comes to the different user interfaces for what application they're implemented, you can use this as a reference for the different user interfaces. This is a feature matrix of the different data stores for each application and for what database type it's able to use for caching. When it comes to the exporting data of like exporting to Word, Excel, or PowerPoint, this is a cross-reference per the application and the Microsoft API that you can utilize. Same for the save as JSON. So if you want to save your Word, Excel, or PowerPoint file as a JSON format per the application, this is a cross-reference per that you can look at the application for the available API that you can use. So Explore the World source code. It's out on GitHub. You've seen the links quite a few times. Here's one last look. And the different solutions, we're going to be, we're continuing on with these solutions noted here for part 1, but part 2 is going to be more covered tomorrow. So looking at the Blazor web app solution, you'll notice there's really only 3 different things you could right click on to choose when it comes to the different applications you can start. A lot of the libraries and all that are loaded in here, but that's necessary for the overall application to run. There is a solution out there for Radson in particular. Now, one of the things you have as a workaround is, within Radson, well, first off, I had to create the separate solution and these separate projects because Radson doesn't like to work with Razor files within a Razor library. It has to be within a basically a WASM project type. So I basically synchronize the files between those two, but AI helps me out a lot there as to where that has not been an issue. And then we have the larger solution. I tend to look at this one the most and work with this one the most, to where you kind of can right click and run any of these solutions. So by right click, you can run those, but let's look a little closer at these different solution folders. In the libs folder, there's a lot of different projects to consider. There's the Octane modules, which are kind of wrappers for different UIs within Blazor lib. And then you have the app layer, I call them the AL libs, but really application specific, like front end specific type of libraries. And then we have the business layer library, common layer, and dependency layer. So business layer is really to where you have a lot more of your business logic, commons, like just common code that's used everywhere, base level stuff. And then a dependency layer. So your .al, your .bl, and your .cl, your .dl, is ABCD. These libraries are what holding most of your classes and interfaces. So then you have the different implementations. So within the DL libraries, you'll have, like, for example, the data access implementations. And when I think DL, I'm not so much thinking the data layer, I'm thinking the dependency layer. So where when it comes to accessing data, if you're trying to work with SQL Server, well, it has its dependencies. If you're trying to work with Access, it has its dependencies, or local storage. So the structure of how we implement things is managed this way within these project types. Similar with the JavaScript implementations. We're going to be looking at these a little closer later. But yes, try to separate your JavaScript implementations as well. When it comes to the different Office APIs, those are well segregated for the purpose of this presentation of this source code. I do have two other libraries out there, MS System and MS System Net, which I normally implement some file system type aspects in there, but they're pretty much empty libraries at the moment. So the core architecture itself, I'll try to, before we kind of look at some code here, I'll try to make this as clear as possible. So we have our applications that work through a lot of application libraries. So I try not to put a lot in the app itself. I try to put more into libraries so they could be reused. And we do this a lot as software developers. And then, they have a reference to a lot of these common classes when it comes to business logic and, interfaces for data and just DTOs, common classes, and so on. Now, the AL library does have references to all of the three others, the business layer, common layer, and dependency layer interfaces and classes. Now, the business layer has no dependency on the AL layer, but it does have a dependency on the common layer and the dependency layer interfaces and classes. Now, the data implementations has a dependency only on the data layer and the common layer. Cannot access the business layer directly, the business logic. And then the application itself is what has a dependency on the one or more implementations. So the application, when it's running, it's going through the business layer because of how data is injected. So a lot of us .NET developers are comfortable with dependency injection. We're going to get on the same page here when it comes to looking at some example code, but dependency injection is your friend, not only for like data access, but also for working with JavaScript. And we're going to see those examples. So to kind of summarize this diagram, we have, most of your classes and interfaces, are inside of these four libraries. The apps themselves are just entry points, and they control the references to your different implementations. A lot of the screens and all that are really inside the libs. So yes, most UI implementations are in the AL lib or .client projects. And the business logic, a lot of the deciding what to do, a lot of your if-then logic is inside of your business layer, but the data is injected as interfaces. And when it comes to any external references, that's where those are good to wrap up in some kind of implementation project as such. So whatever those external dependencies are, it's good to wrap those up outside of your other classes. So this is an architecture that's based on managing dependencies. And so your applications and your other projects aren't getting cluttered with these different references everywhere. You could pretty much contain those where they need to be contained within the different implementations. So the application layer itself, there's a lot of different aspects that are implemented, whether it's the web app, these different add-ins, WinForm, Maui. When it comes to the Blazor code, that's pretty much all in the Blazor lib, except for the web add-in. There's more code that I have to kind of move into there. So at the moment, it doesn't have a direct reference and utilize it as much. But the plan is to really have everything go through Blazor lib for its UI components. So next we have this packages folder. That's it, solution folder. And this is a coding pattern I've been doing for a while, to where you have your packages where you want the source code of those packages before you want to maybe make them a NuGet reference. So looking at like this NetOffice 10, which is something that will be talked about more in part 2. We have this is the way I kind of expect the structure is that I recommend a structure where you have like by owner name and repo, but as long as that NetOffice 10 repo is alongside the same repo as this one, it'll work just fine. So it'll use that relative reference. And yeah, it's a good way to kind of incorporate source code from a package without having to reference the package itself. And the test folder. So there's a lot that is available when it comes to test. We have test on, web test, we have desktop test, and so on. The test folder itself is utilized to where when you run a test, it'll output a before and after screenshot as well as a little recording, which is nice. It uses Playwright for the web test itself, uses a Fly UI for automating the Windows desktop for different tests, and the README with inside of the test results, because I don't really put the test results out there in source control. I probably should, but I don't at the moment. The README is pretty explicit on how these, on what's available for these different tests. And the last solution to look at, which we're really not going to look at any further, but it's more so to make you aware, there is this .NET framework specific solution. So I tend to separate framework references. Even though you can combine multiple targets into one project, I try to keep those separate as much as possible. So underscore netf stands for a .NET framework implementation or solution or project that also links to code. Doesn't have to have a copy of everything, but does link to a lot of the code that's available that can be shared from the top level solution. So leveraging the architecture, when it comes to data binding basics, we'll look at some examples there. Coding patterns for data access and how to best implement JavaScript within Blazor. So let's look at Brent Stewart's Blazor basics again. We'll kind of let some of these demos play out when it comes to components, pre-render forms, persistence and cascading, and JavaScript interrupt. So even though I'm just kind of running the demos from here, this is where if you're not really comfortable or familiar with these different programming concepts within Blazor on how you can kind of pass parameters or even work with child content with a render fragment, these demos are, for one, just kind of good to watch here, but the code itself is, really kind of says a lot too. When it comes to how you handle data binding with the simple at bind or you classifying the event to bind on, or even on specifying like the input itself, which is pretty nice. On click, kind of representing how you can kind of deal with these different handlers behind the code is good to check out. Even on key down, on how you can kind of work with and control that on any DOM. And yes, when it comes to preventing something to happen on clicking, you can do that as well. With understanding component lifecycle, this was a really good demo on kind of recognizing what happens and when a page goes through a secondary lifecycle on a re-render. And on the routing side, when it comes to clicking through, some examples on routes and how they're kind of utilized within the code is nice, even when something is not found as well, like you just saw how that's handled. And then we have a dependency injection on kind of how that works with changing out that greeting. When it comes to pre-render forms, basically when it comes to streaming as well as blocking streaming, these are some kind of newer features in .NET or in Blazor, I should say, on how you can kind of control out of that. And, we even working within a submittal form. When it comes to persistence and cascading values, these are good examples to kind of maybe click through. But again, this is where the code behind, I think, is going to be more useful to look at along with the demo itself. And lastly, JavaScript interrupt. This is one thing we're going to be talking about a lot, but here's a simplistic demo of where you have C# talking to JavaScript. Kind of do the hello Blazor. And also when it comes to JavaScript talking to C#. So resizing a window and getting those values, that's something you have to get from JavaScript. All right, so some coding patterns for data access. This is a good thing to just kind of keep in the back of your mind when you're looking at implementing hooks in the JavaScript. So we have, the web browser and HTML and for how all that works. And then we have, for example, our SQL Server database and what goes on there. Now, as a .NET developer, we've worked with databases for a very long time and from C# and how we would, we really are just executing an SQL command to get to that data. Now, within JavaScript, that which is running within the web browser from C# and Blazor, we need to utilize interrupt in order to get to JavaScript. So in a way, it's kind of like data access. We're just like we're using an SQL command to get to different aspects, like table data and things like that, and a database server, we need to get to the data of JavaScript or in the web browser through JavaScript, most commonly referred to as JS interrupt. For .NET developers, we'll typically use an ORM like Entity Framework or Dapper or something like that to make talking to, or working with SQL commands a lot easier. But of course, the reason we're in C# and we're trying to optimize performance, really control business logic, and have more deployment options for how we're implementing our code, our solutions. Now let's start with this kind of odd idea. And this was not an odd idea, 20, 30 years ago when the internet was first kind of being a thing, which I was there for. So it wasn't a crazy idea, actually, to do a lot in the database, even like serve up a web page. I'm even seeing some of the newer examples doing stuff with like Postgres and things like that. So yeah, you could have a procedure that returns HTML code, but when you see something like this, you hopefully you're shaking your head, and you don't want to do something like this because there's a slew of reasons why you don't want to do this. There's poor separation of concerns. Writing HTML code and in a procedure just sounds painful, even though it's probably crazy performant because you're going from the web browser right to the database to get its data. And SQL Server, it's an expensive rendering engine. When you kind of want to scale, you're going to have to add more SQL Servers instances to really handle that level of performance. So this kind of thought pattern, isn't a crazy thought pattern, but in many ways, when we try to do so much with JavaScript in the web browser, it feels like this for what we were trying to do 20, 30 years ago to have performant websites. So let's follow this example on how we do things today and how we manage database connections today. So this is kind of get us all on the same page of understanding dependency injection and why there's a dependency layer here. So in this example, we have this one DB context for Entity Framework, the Explore the World DB context. that DB context is reused by 7 different implementations of getting the data. So we got the in-memory database implementation for both the server and client-only applications, but then we have SQL Server, SQLite, AccessDB for the server, and then we have local storage, session storage, and IndexedDB for the browser storage that can be utilized. So the application layer, this kind of get us all on the same page of managing dependencies and how this looks. In the component, we inject the service. This is, from the application layer, we inject this countries now space manager service. That particular service has the method of get all countries, and which, is simply to return all the countries. Now within the business layer, the business logic of making the determination, should I get the data from the database or from the API? Well, that's handled in the business layer. There's some logic here that needs to be handled. So what it does is that it checks to see, is there any data in the database? If so, return it. It doesn't have to go to the API. But if it doesn't find any data, it will go to the API, and for that data it pulls back from the API, it'll put it in the database right away and then return those results. So we have some logic here that's handled in this business layer. We also have this DB manager variable in this API service, maybe not the best name, but API service variable as well. Now those are getting injected into this particular service. So these are kind of data dependencies. We need, the service needs to get its data from somewhere, and that's what's getting injected here. So within the application layer, when the application starts up, and this is, again, trying to get us all on the same page of looking at dependency injection across our .NET applications nowadays, we have, this particular service getting added to our overall services that can be utilized on startup. Some of those dependent services are the API service. So this is kind of basically saying to create an instance of that particular service for that interface. And then we have the 4 different in the Blazor web app, the 4 different possible database providers that could be utilized that are also getting created and injected. In the client-only version on startup, something similar, except we are wanting to not only use the in-memory DB provider, but one of the 3 different browser storage providers to be available. And let's explore that one a little closer, in particular the IndexedDB provider. So you'll notice in all the implementations, there's this extensions method for adding these different services a lot easier. To where this one is, adding the IndexedDB repo for that particular API, but then also the generic IndexedDB repo on how you would work with IndexedDB as well. So we look at that specific the API manager repo and how specifically when it comes to getting countries and things like that, how that's implemented for this library. We will notice that the interface for what's getting passed to it is the IndexedDB repo interface, in which we have that storage variable. We're going to take a closer look at that. So inside that IndexedDB repo, this is where we have a wrapper around the JavaScript to work with IndexedDB. So when it comes to get item, set item, the things that, the kind of actions you need to do in order to work with IndexedDB, we have this basically wrapper around the JavaScript. Let's take a look at the JavaScript. So inside the JavaScript file, we have generic get item, set item, I say wrappers, but implementations of working with IndexedDB. So the coding patterns for data access, where we think about data, getting it out of a database, they're not much different, like I mentioned, for using JavaScript. It's just important to wrap them, just like we have an ORM to have more control over our code and how things are implemented. So interrupt is a lot like data access. If you keep that in mind, you'll be able to kind of structure your code and your implementations a lot better. Another example is a new window button. So something simple like this is not so simple in Blazor. But hopefully this helps you understand why. So for having your application open a new window, you could do something like this to where you have an interface that simply has this method of open new window. And in the application layer, you can have this open new window implemented for if it's a browser window. So your Blazor code doesn't really have direct access to the window object or navigator or document object. You need to go through JavaScript to get to those details. And this is one aspect of how you're just going to open to a blank window. And same for a Windows form application. Blazor doesn't have access directly on creating a new window within a WinForm application. So once you kind of get in this mindset of like, oh yeah, that makes sense that Blazor doesn't have access to anything in WinForms, you have to provide a way to get to WinForm features like opening a new window, just the same as you would within a browser. So you start thinking that way, then you're like, oh, okay, I just need to provide that implementation of opening a new window within WinForms. And then when it comes to Maui, having a Maui app, open a new window in Maui as well. You need that implementation because Blazor is just the in between for handling the logic. So when it comes to looking at the best implementation for JavaScript within Blazor, when you have to work with a library that's a little more complex, that does a lot, in the JavaScript realm, well, that's where you truly see a value of having this content separated. So let's take a look at how Reveal.js, this JavaScript library, is implemented within this overall solution. So Reveal.js is this HTML presentation framework that does an amazing job when it comes to doing slides online. Has a really well done API within itself, and yeah, it's totally worth checking out. So a little demo here on the country slides. You have the toolbar above and some navigation below. Even built in, you have some navigation. And for what's going on here in the middle, that's Reveal.js, kind of doing all that heavy lifting. And then across the top where you have the different buttons for navigation, across the bottom where you can jump to different things, that's where you have Blazor calling into the Reveal.js API. So let's start looking at some code. When you look at the markup behind this page, here we have, within the Razor file, we're demonstrating how it's kind of looping over the countries and putting out this HTML of section, div, and so on. Now, it's Reveal.js handles like each section is a different slide and so on. It's something within the Reveal structure way of doing things with HTML elements. So this is what's generating each slide. It's just HTML. And I purposely, you could do like where you encapsulate it as like a, like a Blazor, or I'm sorry, a component, but it makes sense for something like this just to be raw HTML for Reveal. And then those buttons across the top are implemented through like Radson buttons to where it's calling into the API. of reveal. So for example, when you want to click the next slide, it's from that Radson button. It has that click event handler. And within that click event handler, there's a slides interrupt, which gets called. And kind of stepping back from that, that's a reveal.js interrupt interface is actually getting injected into this component library. And just like any other interface getting injected and handled by a real implementation, that's handled within the program startup. So within the reveal.js interrupt, that's what's doing all the heavy work. So the code itself is really just a wrapper that's going to invoke that method of navigate next. And inside the JavaScript, we'll see that navigate next is really just calling the reveal API to move to the next slide by having that simple next method getting called. So the explore the world also goes the other way. For example, we have the full screen. So when a user just presses F for full screen, we want the Blazor application to be aware. So kind of going the other way, within the same JavaScript file, we have a reference back to the .NET application, to where it's going to invoke the method on full screen changed. So by using the JS invocable attribute, which now makes that available for JavaScript to call this, we can then have Blazor kind of call state change to kind of handle some rendering, resizing and things like that as well. And more so in the second part, I just want to kind of share a little glimpse, that I have, where when it comes to the web add-ins and how a lot of working with the Office document models are wrapped up as well. It's a it would be great to kind of share more of that here, but I share a lot of that tomorrow or in the next presentation. You can check that out then. All right, so is Blazor the right choice? Let's look at some decisions and perspectives and recap on the order we're choosing. So a lot of people look at, what is the fastest? And my opinion is that you can really, whatever tech stack you choose, you can make it as fast as you need to. I come back to this example a lot, to where behind the scenes and talking about how this website is so fast, it actually uses an old technology of ASP.NET Web Forms. And when you're looking at, can I make something faster? I think whatever tech stack you're going to use, you can find, you can figure out ways to make it faster. It's a bunch of questions and decisions that you kind of got to work through. This is just probably a handful of, if you're in the Microsoft tech stack already, do you want to continue in it? What are those component suites, existing platforms? Do you need to convert or take a hybrid approach? There's a bunch of questions you should really kind of work through. And the perspectives, heavily weigh the application architecture perspective the highest. Don't compare Blazor to React, Angular, and Vue because you like how you write the code. That is such a low factor on why you would want to use Blazor. You need to understand where Blazor fits. If you're really trying to utilize Blazor the same as you would utilize JavaScript, well, then you're going to be kind of confused for how things work. So recognizing that working with JavaScript is almost like working with a database server. You need to issue commands back and forth, and having some kind of wrapper around that really makes things a lot easier. So the order of choosing, you want to choose your platform when it comes time of actually making the decision. Then you choose your component suite, and then you choose your coding standard. You consider all three of these at the same time, but when it comes to your final choices, that's the order you want to make them. So next steps. You want to look to the experts in open source. Brent Stewart shared his Blazor basis quite a bit, but there's a lot out there in the community with Carl Franklin, Rocky Lodka, Sean Walker, the creator of Octane, Christoph Straub, and you can see the list here. Jimmy Estron, when it comes to training, there's a lot of great content that he puts out as well. Revisit the presentation examples. There's a lot to be discovered there. As for my next steps, I'm planning to add more features to explore the world, sample solutions. And more importantly, I'm planning to extract a lot of features and make them NuGet packages, especially the stuff that's around Office. I'm converting a lot of projects to the Bro stack. I'll be revealing some of those as well in the coming months through some webinars. But there's a lot I think you kind of reuse there once you really settle on the tech stack, how you're moving forward. And yes, I'm going to keep doing more with Office. So when I'm applying the Bro stack, and I'll be releasing my upcoming website in the near future. So I kind of took this a lot further, where you have this article view for that content, or you could look at it like the same kind of slide kind of view, or if the content's up on YouTube, like mine is, you could even toggle to that. So I always found this view of working with content where you could kind of watch or read the content and scroll through it. Did some fun stuff where I took that picture and converted it, used AI to put a voiceover behind it, and that was all generated. So anyway, this is one thing I'm working on. So I'll wrap this up with sharing the bit.ly link again. So at bit.ly, John Beluga VS Live to get to the source code repository and slides. And again, we can work together through advisory, project, or solution. And for larger projects, I can subcontract hourly. The best way to get a hold of me is simply to email me at john@johnbeluga.com. Thank you.